All right, up on the board we have the definition of a logarithm. The two-directional arrow means that we can go both ways, from exponential form to logarithmic form, and vice versa, from logarithmic form to exponential form. So we have this question here to write 9 cubed equals 729, which is in the exponential form, to write it as a logarithm. And it helps to remember that the exponent that we have here in the exponential form is the answer to the logarithm. The answer to the logarithm is an exponent. I.e. the exponent that we have when we're over in the exponential form. So to take 9 cubed equals 729 and put it in logarithmic form here, figure out where to put three things that we have. That 9 cubed equals 729. We have to figure out where to put the 9, the 3, and the 729. And I just indicated that the exponent in exponential form is the answer to the logarithm. The other easy part, relatively speaking, should be what's the base. We're talking about the same base b in both. So base 9. By a process of elimination, third thing, 729, that's what we're taking the logarithm of. That could be read as the log of 729 base 9 is 3, or the log in base 9 of 729 equals 3. What you don't want to read that as is 9 to the 729. That will give you a huge answer. You can type log and then an underscore, which is around the minus sign, it looks like. So log of 9 base 729 equals 3. Now let's convert from logarithmic form to exponential form. We've got the log of 8 base 64 is supposed to equal 1/2. So that answer to the logarithm, 1/2, is going to be the exponent. We've got the log of 8 base 64 equals 1/2. And so that answer to the logarithm is going to be the exponent. The exponent for what? That same base of 64. This is one that you could check on your calculator, but we don't even need the calculator because 64 to the 1/2 is the same as taking the square roots of 64. The principal square root of 64 is indeed 8. This one is also asking us to write in exponential form. Got the log of 9 to the -4 in base 9, write that as exponential form. Log of 9 to the -4, base 9 equals -4. So our -4 here is an exponent for the base 9. And by a process of elimination, the third part that we didn't deal with was what we're taking the logarithm of. So we want to have 9 to the -4 equals 9 to the -4. In this question, we're asked to estimate to 4 decimal places as needed the log of 7 base 3. There is another way that this could be done, but as far as I know, it is not information that is available yet. So we're looking for something that we could raise the base of 3 to get 7. And we know that 3 to the first is 3, and 3 squared is 9. So we're looking for something that is in between 1 and 2, because we're looking for what exponent it would take. Remember, the answer to a logarithm is an exponent. So we're looking for what logarithm would it take, the answer to a logarithm is an exponent. So what power of 3 do we need so that we have 3 to that power equals 7? So I'm going to do some guessing and checking, because again, the other method, something called the change of base formula, is information that's not available yet. Now 7 is closer to the 9, so I expect the answer to be something closer to 2 than to 1. But I'm going to go halfway in between and try out 3 to the 1.5. And that's giving me something too low. So because I'm too low, now I'm going to go between that 1.5 and 2. Let's go halfway in between there. So let's go to 3 to the 1.75 power. That's too low. So again, I'm going to go up halfway between the 1.75 and the 2. That's going to give us 1.875. So let's try raising 3 to that power. And that's too high. So I'm going to back off, go halfway in between, instead of 1.875 and 2, I'm going to go halfway between 1.75 and 1.875. And raise 3 to that power. And as the exponent came down, so did the resulting answer, but it's still too high. So I'm going to go halfway between the 1.75 and the 1.8125. And raise 3 to that power. Still too high. So again, I back off, go halfway between the 1.75 and that 1.78125, and raise 3 to that power. Now it's too low. So I'm going to go halfway in between these two. I'm trying to squeeze this in. And it's a little too high. So I'll go halfway in between these two. So the one that was too low and the one that was too high. Raise 3 to that power. Too low. So I'll go halfway in between the last two. Too high. So I'll go halfway in between the last two. Raise 3 to that power. Too low. So I'll go halfway in between those last two. Raise 3 to that power. And that's too low. So instead of going halfway in between the last two, because those were both too low, you go halfway in between this one and this one. Which both started off with 1.771. And that's too low. But notice how, if we only go out 4 places after the decimal point, it is going to round to 7. And let's see what happens if we do just one more, because the last two were both too low. See if we try out 3 to this power. That, if we rounded it to 4 places, would be 7.0009, whereas the previous one, if we rounded it, would be 6. Well, it would round to 7. So I'm going to take this answer and round that to 4 places. I'm going to try putting in 1.7712. So now we have to solve the equation log of 64 base x equals 3/4. So the answer to that logarithm, 3/4, that's going to be the exponent, and x is the base. Got x to the 3/4. by process of elimination, that would have to equal 64. Now, I could rewrite that as a radical, the fourth root of x cubed, or the fourth root of x. All of that cubed. That's actually going to give us something easier to deal with, because if I take the cube root of both sides, cube root of 64 will cancel on the left, and the cube root of 64 is 4. Now if I raise both sides to the fourth power, cancels out on the left, you get 4 to the fourth, and that should be 4 to the fourth should equal 256. So here we may be dealing with something similar to the last one. Log of 4 in base x equals -2. So -2 is going to be an exponent for the base x. And by a process of elimination, that equals 4. Well, x to the -2 is the same as x squared. Sorry, 1 over x squared. I can multiply both sides by x squared to get rid of fractions. Divide both sides by 4 to isolate the x squared. And because the only place x shows up is as part of something squared, I can take the square root of both sides, cancel out the x squared, but there's going to be a plus or minus. Applying the quotient rule. Split up that fraction. Take the individual square roots of the numerator and denominator. X would equal -1/2 or +1/2. However, x is supposed to be a base in the original. Both of those numbers are solutions to this exponential. Well, it's not even an exponential equation, it's a quadratic equation. But in the original, we're talking about a base. And a base must be positive. So I'm going to reject the -1/2 and just put in 1/2 for my answer. This next one on the surface might look similar to the previous two, but this time we know the base. Log of square root of 64, base 4, equals x. So, our base is 4, and our answer for the logarithm is x. That's our exponent. Towards the x equals square root of 64. Rather than calculating square root of 64 and perhaps making it more difficult, I'm going to write square square root of 64 as 64 to the 1/2 power. 64 itself is a power of 4. 4 squared is 16, and 4 cubed is 64. Those exponents right next to each other, we multiply them. Four to the x equals 4 to the 3/2. Because of the one-to-oneness, if the output is the same for y equals log of x base 4, then the inputs have to be the same. And we set the exponents equal. X equals 3/2. And that's already in a simplified form. (1024) is 2 to the 10th power. So we can rewrite that as log of 2 to the 10th base 2. And because we're dealing with inverse functions of each other, y equals 2 to the x and y equals log of x base 2 are inverse functions of each other, then we have a composition of two functions. They're going to undo each other. And one of the properties would just tell us that we're left with the exponent at a regular level, canceling out, giving us 10. You could go back through using the definition, but it's going to take you longer to do that. Finally, if we want to graph y equals log of x base 2, I just indicated that we have inverse functions here. So if we were going to graph the first one, the exponential function, we don't need a lot. We could put in 3 special values of x. Ones that if you have a non-negative, if you have a positive base, then raising 2 to the 0, that's 1. 2 to the first is 2. And 2 to the negative 1 would be 1 over 2 to the positive 1, so just 1/2. That would give us, on the first one, 3 points, negative 1 comma 1/2, 0, 1, and 1, 2. Those would be points on the graph of the first one. So points on the graph of the second, because they're inverse functions, switch x and y. 1/2 negative 1, 1, 0, and 2, 1. Plot those 3 points and connect. (1/2 negative 1 is about right here. 1, 0 is an x-intercept. and 2, 1. It will not cross the y-axis. The y-axis is a vertical asymptote for this function. So it never crosses it. X cannot equal 0, and X cannot be negative. So looking at my options here, one that looks the most like it all good.